Coach Luke, and we're back with more geometry. I'm going to be coaching your way through proofs today.
Yay!
First, we're going to start out with our congruence theorems. A congruence theorem is any way to prove two triangles to be congruent to each other. So, will one of my lovely assistants take over?
Alright, so this first theorem is angle, side, angle, which means...
This can be described as two angles in the included side of one triangle are congruent to the corresponding parts of another triangle. The triangles are congruent.
So basically what that means is that when you have two angles and the side in between them and two triangles with the same thing, those triangles must be congruent.
Yay!
Alright, now we have a theorem that a lot of students get tripped up with and they think they can use.
I feel like we should put this at the end. You know, like go through all the theorems and be like, oh
Yeah.
wait, this is the end. Not to like interrupt the video, but I'm just saying.
Yeah. Okay, so now we're going to go through some congruence theorems. Kelsey, would you read us the definition of angle, side, angle?
I sure will. Okay. If two angles in the included side of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent.
Our model, will you please come demonstrate this for us?
So basically that means that if you have these two angles here on both triangles, the side in between, then those two triangles are congruent. Yay!
Okay. Another congruence theorem is side, side, side. Kelsey?
If three sides of one triangle are congruent to three sides of another triangle, the triangles are congruent.
It's pretty self-explanatory.
Yay!
Yay. Alright, another one. Side, angle, side.
If two sides in the included angle of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent.
So you have these two sides and the angle in between them, and if those are congruent to those, then the triangles are congruent.
Woo! Alright, and then angle, angle, side.
If two angles in the non-included side of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent.
So when you have these two angles, but it's not this side, it's this side instead, and you have the same thing over there, then those triangles are still congruent.
And whenever you're writing a proof, you can always abbreviate the congruence theorem just with the letters it represents. Okay, so this one we have a big disclaimer up top. It's only for right triangles. This is hypotenuse leg.
If the hypotenuse and leg of one right triangle are congruent to the corresponding parts of another right triangle, the right triangles are congruent.
So here's your hypotenuse, and here's your leg, and it's the same for that one, so those triangles are congruent.
Yep, and we already know that they're right triangles because they have right angles.
Yes.
Alright, so now... So this one is one that a lot of kids get tripped up with and they think is a congruence theorem, but really it's not. It's a naughty, bad, wrong
The donkey theorem.
Yes.
Yay!
Which basically, you can't have two sides and an angle that are right next to each other, and that is not a theorem.
Angle, side, side. Figure that out.
It doesn't work.
No.
It won't prove a triangle to be congruent to another triangle.
Yep.
Don't try it.
Don't try this at home, kids.
Or in school. Okay, so this is the basic form for setting up any proof. You have a column with a statement on one side and a reason on the other. And you always, always, always start your proofs with your given. The first statement is whatever you've been given in the problem, and then your reason for that is that you were given it by the problem. And then always, 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 your very last step of the problem is whatever you want to prove. So whatever the problem asked you to prove, you have to do in the final step. And the reasoning for that is some congruence theorem, which is what we've just gone over. So, to do the next proof, we are going to talk about a couple things that we're going to need to use in it. Carly, will you take this one away?
So the first thing is the reflexive property. And what that means is that any quantity is congruent to itself. So when you have these two triangles here, since they share the same side, this side on this triangle is congruent to this side on that triangle. It's the
kind of makes sense. It just says that something is the same as itself.
Reflecting, so it's the same.
Yep. And another thing that takes proofs one step behind congruence theorems is CPCTC. Someone take that away from me?
Corresponding parts of congruent triangles are congruent.
So this means if we've already proved two triangles congruent, we can say that another part of them that we didn't use to prove them congruent is also congruent to the other triangle. So Carly, can you help me show that?
For example, in these two triangles, it seems like we've already used side angle side to prove that triangle A is congruent to triangle B. So after we know that they're congruent, we can also say that this side must be congruent to that side.
Yeah. Alright. Okay. So now, we are going to start with a proof. Cut. Now, we are going to do a workout to get ready for the race. We're going to do a sample proof. Alright, Kelsey, would you read me what the question asks?
I sure will. Okay. Quadrilateral ABCD with side AB congruent to CD, AD congruent to BC, and diagonal BD is drawn.
Alright, Carly, will you draw those in for us so we can see them better?
So it says AB, which is this one, is congruent to CD, which is that one. And then it says AD, which is this one, is congruent to BC, which is this one.
Okay. And what did it ask us to prove? Can you also draw that on there for us?
Yep. It says prove that angle BDC, which is this one, is congruent to angle ABD, which is this one.
It's always very helpful to draw on the picture of the proof exactly what you are given and exactly what you want to prove so that you know when you're done that you have correctly solved the proof and you have the answer that they wanted.
Can we align it?
Yeah. We're going to align this really quick.
Yay, proofs!
Proofs are kind of a logic game. You have to follow a series of steps to get to what you want. And you can't leave any out or else it doesn't make sense. So Carly's just going to redraw what we have been given on our picture, and she's also going to draw in what we're trying to solve for and say that it's congruent. Okay, so on this one, like we've said before, with every proof you ever do, you are always going to start with your given. So, we're going to look back really quick and see what we were given so that we can write it in. Sorry. Okay. We were given quadrilateral ABCD with these sides said to be congruent and a diagonal drawn. So that is everything that we're going to write. AB congruent to CD, AD congruent to BC, and diagonal BD. And our reasoning for the first statement in any proof is always that it was given. Thank you. Okay, so now, my two lovely assistants, before we can say that the angle ABD is congruent to the angle CDB, how are we going to prove these triangles congruent first?
Wait. I know what we're not going to do.
What are we not going to
The
do?
donkey theorem.
We are not going to use the
Angle,
donkey
side,
theorem.
side. No,
We're
wait.
not going to use that. Carly, what are we going to use?
We can do side, side, side.
How are we going to do that? Where's the third side? I only see one more side.
Oh, we learned about the reflexive property.
That's right. We're going to say that BD is shared by both of the triangles, and so it is congruent to itself. say that BD is congruent to BD itself. And our reasoning, as we just learned before, is called the reflexive property. There we go. Okay. So now, if I write this in, ladies, do we have enough information to conclude that these two triangles are congruent?
Yes.
We do. Okay. So, we can say that triangle ABD is congruent to triangle BBC. And what theorem are we going to say that proves this?
Side, side, side.
There we go.
Nice job.
All right.
But wait, don't we still say that those angles are congruent?
Correct. We aren't done. What were we asked to do in the problem? I'm going to look back at it really quick. And then our lovely, very enthusiastic about proofs, Kelsey, is going to help us with it. All right. We were asked to prove angle BBC was congruent to angle ABD. All right. Kelsey, will you do it for us?
Yeah.
What can we do?
Well, we can prove that those angles are congruent to each other because of CPCPC.
Oh my goodness. What does that stand for again? I can't remember.
Congruent parts. Corresponding
Corresponding.
parts.
There we go.
I remember. Something about the
Carly
same
remembers.
Corresponding parts of congruent triangles are congruent.
Yeah, I have the same thing. Yeah.
It means if they're in the same spot on each triangle and the triangles are already congruent, those angles too must be congruent. Would you like to write it in for us, Kelsey?
I sure will. Okay, maybe. So, angle ABD, and that's what we were set out to prove in the first place, is it's congruent to angle BBC. Because that was in C. Okay, fine. C, 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 C.
All right. We're going to look back really quick. Are we set? Have we proved what we set out to do?
Yep. Yes.
That means we are done with this proof. All right.
Nice job.
Let us move on. I'm going to let the ladies take this one away for me.
Hard.
All right. So we are going to meander over to the board. They're going to get started here. I'm going to help set up the problem for you. So this one asks us to prove that these two triangles are similar to each other. Not that they are congruent. It is very clear that this triangle is much bigger than this triangle. So I'm just going to go on this board and highlight everything that we're going to need. Alright, so the given is, the diagram below shows angle ABC with AEB, ADC, and angle ACB congruent to angle AED. We are asked to prove that. Here. Triangle ABC is similar to triangle ADE. Alright, and we have set up our statement and reason table. Alright, ladies, are you ready to take it away?
So ready?
Alright.
Okay. What?
Oh, so we should first probably label what they gave us, right?
Tell me what they
Alright,
gave us.
so they said the angle ACB
ACB.
is congruent to angle AED.
AED.
Yep, and we're trying to prove that triangle ABC
ABC.
is similar to triangle ABE.
AD. These two are right, right?
Yeah, alright. So our first statement and reason is going to be our given, right?
Yes, ma'am.
Would you like me to read that to you,
Yes,
Carly?
please.
Okay. Triangle ABC. Alright. Line segment AEB. Line segment ABC. And angle ACB congruent to angle AED. Alright. And what's our reasoning on that?
Given!
Given.
No one should ever get that part wrong.
I think we should get a new marker. There we go. Okay. Alright,
important, so we
ladies,
gotta
take
have
it
it.
away.
Alright, so
It is a very important step. You are correct.
the way to prove that two triangles are similar is by angle is congruent to angle, right?
Yeah.
I'm going to write that right here. Alright, so, do you see any angles we have? Well, we got that one, but that's our given. What else?
I'm just not sure.
I'm
Oh,
going to
wait.
jump in here really quick. I'm going to say sometimes when you're trying to prove something, it's helpful to write what you already have. We're looking for two angles, right? We've been given one in our given. So I'm going to write a little 1 here. That reminds me that I only have to find one more angle to prove congruent to another angle.
Okay.
Take it away, please. What about this one?
Yeah!
They
'cause they're all
share
the
it.
same triangle.
Oh my
It's
goodness!
the reflexive property. Duh! Alright.
Sometimes the easiest ones.
They just pop out at me.
Alright, so angle,
BAC.
yep, it's congruent to angle BAC.
No.
Yeah.
EAD.
What's the same
This
thing?
is a different triangle. No. I'm right different.
Because they're pretty much the same angles. They actually are the same angles. So that's just a reflexive property.
Yep, we said that anything is equal to itself. Makes sense. I've always thought it was a very silly theorem. But useful.
Should be. Okay.
Alright,
That's all we need, isn't it?
is that two angles?
Yeah.
Angle.
Yes.
C.
Alright, so now we just write
The triangles are congruent to each other.
triangle ABC. Similar.
Ooh, they're not congruent.
Oops.
Be very careful.
Similar to triangle ABE.
Triangle AEB.
ABE. And this is because angle is congruent to angle.
Are we
Okay.
done? Yes. Alright. We're just gonna... Alright.
Nice job.
So now that we've had our time trial here, I hope you all ace the regions, ace the tests, and you kill that race, beat everyone, and get 100. Knock down those proofs one by one. Wasn't that fun?
Proofs are amazing.
Proofs
You
are
love
fun.